All right, lesson 4.1 is about congruent figures, and our objective is to recognize congruent figures and their corresponding parts. So the first theorem we're going to learn is theorem 4.1. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Since we know all triangles have to add up to 180, if two of the angles match, there's only one number left that the third one could be. So in this case, angle C and angle F would be congruent. Congruent polygons are polygons with congruent corresponding parts. So if we look at our example over here, angle D has 3 marks, angle G has 3 marks. Those two are corresponding parts. Angle F has 2 marks, angle I has 2 marks. Those are corresponding. Angle E and angle H have 1 mark. Those are corresponding. So then, if we look at the sides, DE corresponds with HG. FD corresponds with IG. IH corresponds with FE. So their corresponding parts are congruent. So if I say triangle FED is congruent to triangle, they have to match. So we started with the one with 2 marks, IHG. So when you list them, the corresponding parts have to be written in the same order. So like we started with the angle with 2 marks, we moved to the angle with 1 mark. Here we started with the angle with 2 marks, moved to the angle with 1 mark when we named it. Okay, so always list the corresponding parts in the same order. Okay, let's look at some examples. Here in number 1, it says naming congruent parts. Triangle ABC is congruent to triangle QTJ. List the corresponding sides and angles in the same order. So if angle A is congruent to angle Q, those were the first two named in each triangle. So angle B is congruent to angle T. Angle J is the third one in the second triangle. So angle C is congruent to angle J because it's the third one in the first triangle. Okay, then if we're naming the sides, side AB is congruent to QT. AB were the first 2 letters named, QT were the first 2 letters named. TJ are the last 2, so it would be congruent to BC. Then AC, that's the first and last letter. AC, so we need QJ. They should always match whatever you have in the congruence statement. Okay, so then let's look at number 2, using congruency. Use the triangle angle sum theorem and the definition of congruent polygons to find the measure of angle X. So we know that angle X, Y, and Z have to add up to 180. And up here it tells us that the 2 triangles are congruent. We know angle M is 48 degrees. Angle M is the last letter here, so it's congruent to the last letter in the first triangle. So the measure of angle Z is congruent to the measure of angle M, which means angle Z is 48 degrees. Then it tells us Y is 67 degrees. So we can replace Y with 67 and Z with 48. If we add those up, we get 115. And then if we subtract 115 from both sides, we get 65. So it's just using what we know about both triangles to solve for one angle. Let's take a look at number 3. It says, can you conclude that triangle ABC is congruent to triangle CDE? If triangle ABC is congruent to triangle CDE, then angle BAC BACs would be congruent to, well, they did BAC, so we would do DCE. Okay. The diagram shows that BAC, so this angle, and here they give this angle 1 tick mark, they give this angle 1 tick mark, so they actually think that that angle is congruent to DEC, not DCE, which it should be based on what they wrote up here. The statement triangle ABC is congruent to triangle CDE is not true. They wrote the letters in the wrong order. They didn't match up their corresponding parts. Notice, if you look at the diagram over here, side BC is congruent to side DC. Side BA is congruent to side DE. And side AC is congruent to side EC. Also, angle CBA, so CBA would be congruent to angle CDE. Angle BAC would be congruent to angle DEC, which is what we had up here. Then, using theorem 4.1, you can conclude that angle ECD, so ECD, this angle over here, is congruent to angle ACB. Since all the corresponding sides and angles are congruent, the triangles are congruent. They just wrote the statement the wrong way. The correct way to write this is triangle ABC is congruent to triangle EDC. Okay, so you have to make sure that you write it so that the corresponding parts are in the same order. So like A corresponds to E, B corresponds to D, C corresponds to C. In this first one up here, if you look, they had A corresponding to C and then C corresponding to E. That does not work. Okay, so then you got 3 check for understanding problems for you to try. It tells you these 2 triangles are congruent. You're going to list all the corresponding parts using the letters. So you should have 3 angles, 3 sides that are corresponding. Then, still working with those 2 triangles, it says if y is 35, find k. And then explain y down here. Make sure you explain it. And then here it says, can you conclude that triangle JKL is congruent to triangle MNL? Be careful. Pay attention to your tick marks here. Those will help you decide. All right, let's take a look at number 4. Okay, number 4 is a proof, and you're going to have a chance to do one of these on your own, but let's check this one out. CG is congruent to DG. CG congruent to DG. They marked that. That's given. CN congruent to DN. They marked that also. That's also given. Okay. GN is congruent to GN. There's a property that we learned in chapter 1 that proves this. It's called the reflexive property of congruence. Okay. So then it says angle C and angle D are congruent. Well, they marked those here too, so that's also given. Anything that they've marked for you is given. Okay, then it says angle CNG. CNG would be this right angle. is congruent to angle DNG, this right angle. So those are congruent by the definition of right angles. Because if all right angles aren't 90 degrees, then they're not right angles. Okay, so then we only have one angle left that's not, we haven't confirmed that it's congruent yet. We did CD and N, the N angles here. So now we need to prove that angle CGN is congruent to angle DGN. Well, we learned that theorem that said if two angles of one triangle are congruent to two angles of another, then the third angles are also congruent. And that was theorem 4.1. So by the definition of congruent triangles, we just proved all the corresponding parts are congruent. We know these two triangles are congruent. Okay, then number 4. Number 4 is a proof. You need to try this. You can do this. I know you can. I'm going to give you a hint right away. It tells you angle A is congruent to angle D, and angle E is congruent to angle C. Okay, it tells you that with the marks that it put on there. So those are given. Then you need to prove the third angle on step 2. Here, we're going to list all the sides that are congruent. So AE has one tick mark. That would be congruent to CD. CB would match EB. So CB is congruent to EB. And that leaves us with DB and AB. Okay, that is also given because they put the marks there for you to see. Right? Then you should be able to prove that the triangles are congruent. So all you have to do is figure out how the third angle is congruent and why that proves the triangles are congruent. So go ahead, give those check for understanding problems a try. If you have questions, make sure you're asking.